anywhere else? No? I'm wrong? Okay. They love them. Okay. All right, this is a new idea, but I promise, it's not that bad. A titration. If you had chemistry last year, you already know this. And look, titrations actually are extremely complicated in chapter 15 and 16. But we're in chapter 4. So all we have to know is the basics. Titration takes advantage of the fact that when an acid and base are added together, they become neutral. Neutral means that you have equal moles of, that says moles, I promise, H plus and OH minus. All right? So what we use a titration for is if I don't know the amount of moles of OH minus in my base, I can add acid until it becomes neutral, and then the amount of moles that was in there is equal to the amount of moles that I added.
But you need to know the mole of your acid.
Right. You have to keep track of your acid that you add and its concentration, but that's not that bad. Like, we can do that. So it's kind of like, let's say we're going to a party and there's a bunch of girls in there, but we don't know how many. So we just send 30 boys in and 10 boys come out all alone. Now, I know there could be some other ratios going on here, but that probably means there are 20 girls in there, right? Reasonable. Yeah, could be. I chaperoned the dance, and I couldn't even tell you 90% of the people that were are on dates there. So really, the boys starting to dance together now and the girls, so who knows what on earth was going on. But are you kind of all right with the analogy? We're going to use a known thing to identify an unknown thing. It's very complicated later, but for right now, it is not. Where on earth did this go? Okay. So here is how this works out. Oh, erase that. Spoiler alert. All right. So a question would say something like, it took 40 milliliters of 2 molar HCl to neutralize 75 milliliters of an unknown concentration of a base. What was the concentration? All right. So to do math for titrations and dilutions, we simply have this following sentence. Multiply the pair and divide that answer by the loner. Did you say you don't get it? Oh. Right. Now, I was gonna use that on the next, when I go back. But to find the pair of numbers, they're always connected by the word of. So I go back here, and it's already circled. But you'll see that these two numbers are connected by the word of. So guess what? What do you do with them? You multiply them. Then, do you see there's this number all out here by itself? So what do you do with that? You divide your answer by that. So you multiply the pair and divide by the loner. All right, so what do we think about that?
Awesome.
Well, we're learning one other thing. It's okay. And it is called a dilution.
Wait, we have another one?
Uh-huh. A dilution is when you have something concentrated and you dilute it. Now, if you're diluting something, your original moles is still the same as your final moles, right? So really, you don't need to overthink this. To do a dilution problem is the exact same process. You're going to have a volume and a concentration, and then you're going to add a volume, and you're going to find the new concentration. It's the same math. The math sentence was to remember was multiply pair and divide by the loner. dilution is when you make your orange juice and you have your one thing that's concentrated, dump it in, and then add 3 things of water, right? The amount of actual orange juice concentrate is the same whether you have 1 can or 4 cans. The 4 was just diluted. You with me? Okay? So the amount of actual like orange juice stays the same. You just dilute it. Okay, I'm going to read you a question directly off the test. This is number 5 even, and I will read it word for word, and I want you to figure this out. It says, all right, and I'll read it a couple times. How many milliliters of a concentrated 6 molar HCl acid need to be diluted to make 1.5 liters of a 4 molar solution? So I gave you 3 numbers. I'll read it again. So it says, how many milliliters of a concentrated 6 molar HCl acid need to be diluted to make 1.5 liters of a 4 molar HCl solution? One more time. Okay. How many milliliters of a 6 molar acid need to be diluted to make 1.5 liters of a 4 molar solution? All right, what 2 numbers are together? What number was alone? 1 is wrong.
1,000?
1,000. Okay, don't fall for my crap, all right? Your calculator will say 1, and that's correct, but in that problem I asked for milliliters, but the other number I give you is liters, so make sure that you put it in liters. So, sorry. Make sure you put it in milliliters. I'm a good teacher. All right. You okay with that? I will read you the other one, but I won't tell you the answer. Okay. It says 65 milliliters of a solution of nitric acid is titrated with 40 milliliters of 2.5 molar NaOH until the solution reaches a neutral pH. What was the concentration of HNO3? I'll read it one more time. 65 milliliters of a nitric acid solution is titrated with 40 milliliters of 2.5 molar NaOH until the solution reaches a neutral pH. What was the concentration of the HNO3? So don't say that out loud, but could you identify a pair? Could you identify a loner? Okay. Now, in this problem, the loner was very first, and it was very first in the other one. It is not always very first, though. Okay? Chemistry is so hard, because once you figure it out, then you've actually stabbed your own self in your own back, which is hard, but it's doable. Okay? It can be wherever it wants, but the ofs will always be together, or the pair will have the of in the middle. You all right with that? Okay. What I want you to do now, and we'll continue on, but that is the end of new stuff. I totally forgot we had this part, but that's not that hard, right? I hope. Okay, now, this is a study guide that I want everyone to pick up. You can keep this the rest of the year. Pick this up real fast, and then we'll talk about it. You don't need to write it down. I'm going to assume that you'll be honest and return it eventually. Okay, so that study guide, they call them topics instead of chapters, but it's the same idea. So just real quick, look at topic 4, and that would be our chapter 4. You don't need to get it out, it's not that big a deal. So what this does is it kind of shortens up each chapter and gives you just the meat.
Thank
Well,
you.
you're welcome.
It's okay, I return that chemistry book.
No, you really do need the book.
Okay.
I expect you to learn a lot from that book that most of you just use as a paperweight. But anyway, this, because you have a 3-day break, right? Well, 4-day, and you're not testing till Tuesday. This can be a very good resource to help you study. It has a practice test in the back, not the back of the book, but at the end of the chapter, it has practice problems. One of the test questions is very similar to one that's in this section. The answers are just a couple pages after. It will help you to review. I don't know, use it for what you want, but it can be extremely useful for the rest of the try. Sometimes writing chemistry questions is really hard. You can't just make them up. You need certain values. So I have used this book myself to write some of your test questions. Okay, I might change a number so that you don't just memorize that the answer is like 4.8, but the process will be exactly the same. So there's no assignment from this at all. It's just yours to help you study for the test. Fair enough? All right. Now, I hope that you're all right with the math. The only math on here is the giant one, then the dilution, and then the titration. Both of those were multiply pair divided by loners, correct? Now, since I won't be here next week, I've decided to break your test up into 2 parts, which is always multiple choice and free response. But you'll do the free response on Tuesday and the multiple choice on Wednesday. That way that's 2 days. Monday, you're going to watch a video of me reviewing with you. It'll be very boring. Thursday and Friday, it'll probably be a video of either me or Khan Academy or something introducing Chapter 5, which is on enthalpy. It's your introduction to thermodynamics, which is not as bad as it might sound. All right, let's real quick talk about, so we did the math. I'm not going to write this down or anything, but I'm just going to explain. One of the questions on this test is a lab-based question. When I am here, I usually make you do the lab as part of the test. This time I'm just giving you the results you would have got by doing it yourself. So what you have, and you did a homework problem just like this. You have 3 unknown things, and you're going to use 2 reagents to figure out what's going on. When you add those 2, they're going to form precipitates or not form precipitates, and that information should lead you to know what the 3 unknowns are. Now, in able to do that, you'll be given this. Double check that the one on your paper at the bottom has C2H3O2 minus written, that it is soluble with no exceptions. Anyway, so you'll notice, you can look from there and see. I'll have a paragraph, I have the data table, and that I expect you to justify and explain how you identified the 3 unknown solutions. The key is that one of the solutions won't form any precipitates. And you'll look at the things and it should make sense. One of them will form 2, and it should make sense why, and one of them will form 1. And using that and what you know, you should be able to explain pretty easily what's going on. You kind of all right with that? Okay, now, let's just review a couple things real fast. Where does the multiple choice usually come from? From your reading. Okay? There will be multiple choice questions that I have not said directly out loud with my voice. There are things that you should read that will tell you some of the answers to the multiple choice. All right. Question number 9 on your exam has A through D parts. And it says, balance and answer the following questions relating to the following reactions. Include states of matter and all species present. If the reaction is a redox reaction, indicate the element reduced and oxidized using brackets. Include the number of electrons transferred. If it is a precipitate reaction, write it in the net ionic form. Okay, so a lot of you probably might not think that you know what you're doing on redox reactions. The book, this study guide, and the next 5 minutes of your life might help that. So one of these questions, and I'll change it a little bit, but it says that calcium is added to, nitric acid. And then it asks you a question. All of them will be this format. It gives you a reaction, then asks you a question. What element is oxidized? Okay, so follow me here. This reaction obviously must be a redox reaction, right? Because I'm asking you what was oxidized. So to get full credit on this question, you first have to write and balance the equation or reaction. So, no, because the directions told you to balance and answer the questions. So Ca, and what would its state of matter be? Solid, is added to nitric acid. Anyone know the formula of nitric acid? All right, good. If you didn't know that, you should for the test. I promise you it's on there. Is it a strong or a weak acid? Strong. If you don't know that, you should, because I promise you that is on the test as well. If it's strong, that means you write it as AQ. And I don't know why. I did this last hour too. Why am I writing? You write an L, liquid. All right, now what is going to be formed over here? All right, calcium nitrate and H2. That will be gas, right? What about this? Will this be a precipitate or aqueous? How come? Okay, nitrate is always soluble. Your solubility rules would tell you that. All right? Okay, so this would be your reaction, and now you would balance it. So the next thing, you would have a 2 right here. You put a 2 right there. That makes 2 NO3s. You already have 2 NO3s. So this is the balanced reaction. But wait, there's more. It says in the directions, indicate the element reduced and oxidized using brackets and include numbers of electrons transferred. So now we have to do oxidation numbers. What's the oxidation of calcium? What is it over here? +2. Because it's a monatomic ion, which means its oxidation number equals its charge. All right, what's the charge of hydrogen right here? 0. And what is it over here? +1. All right. So, do I need to worry about the N and the O? Are they going to change? No. NO3 is together on both sides, so don't waste your time. All right, so calcium changes, right? So, we'll go blue. So we would put a little bracket from calcium to calcium. It went from 0 to a +2, which means it lost electrons, or, hey, it's right there. It is oxidized. All right? Now, it was oxidized and it lost how many electrons? 2 electrons. So like ox and then 2E minus, that would be what I'm looking for. Down here, hydrogen went from +1 to 0, so it was reduced. And how many electrons? 1 electron, because you went from +1 to 0. Now that doesn't seem right because you had 2 up here but only 1 down here, right? But how come that does work?
There's 2 H's and 1 Ca.
Okay, good, because 2 H's lost 1 each, 1 Ca lost 2. So the exchange is 2 both directions. You do not have to write half reactions till a much later chapter. Okay, so to get full credit for this problem, you have to have everything that's written right here. Ignore this is oxidized part. Well, how about I erase it? Then it'll be easy to ignore. All right, that would be full credit for this question. So remember, answer the question. It asks which one is oxidized, right? And write in balance and include the number of electrons transferred. Okay? This one is almost exactly the same as the one on the test. Okay, let's do another one. This one's hard. This one, I would bet over time, above 90% of students get this wrong every test. So it will say solid sodium sulfite is added to, we'll go nitric acid again since we know it. All right, and then it'll ask a question. What is or are the spectator ions in the reaction? Okay, so the first step is to write out and balance this reaction, right? Okay, give it a shot. Let's go ahead and do this. All right, so sodium sulfite, that's the part that you're going to screw up in the long run usually. Na2SO3 is added to nitric acid, HNO3. So this would be solid, right? This would be aqueous. And then most people get the products wrong. This produces NaNO3, solid or aqueous? Aqueous, how do you know? All right, they're both soluble. Plus, then you get in trouble. It produces H2O, liquid, and SO2 gas. How many had that right? 1. So that goes along with my trend of 90 plus people get it wrong. Now, we didn't actually answer the question yet. What is /R the spectator ions here? I think someone mumbled it. NO3 is the only spectator ion. What? What part don't you get? I get the water from right here. You most likely put H2SO3, correct? That would be called sulfurous acid, but that is not what this produces. When an acid reacts with a sulfite, it produces a salt and water and sulfur dioxide. And no one this hour has said it, but it was so awesome last hour. Kids like, how on earth am I supposed to know that? Well, I made you put a box in your notes that was a little red flag, and I drew a flag, and I said these 3 things will produce a gas when they react with an acid. What were the 3 things? Obviously this one, right? Sulfite and carbonate. And one more. Say it, Quinn. Sulfide. Sulfide. Okay? So I'm definitely not trying to trick you because I'm giving you this problem in advance. But remember that little part, that box we put on purpose. Did you find a box? Okay, well, carbonic acid is still, that's carbonate. It's H2CO3. Was it in a box in your notes? Miss Note Taker? Yeah. Okay. Carbonate. Those 3 things. All right. On the test, I got sick of kids getting this wrong. So I even made the ITE bold in the question to try and why did he make that bold? So try to remember, Tuesday's a long time from now.
What is it,
Sulfide and carbonate. Yeah, go ahead. Good luck. Well, you're not running, right? Have fun, though. That's a fun meet. There's like 2,000 people. Okay, yeah, that's why sodium is not the spectator. Because it was never aqueous at the start. So yes, it is at the end, but it was not at the start. All right, we okay with that? Ish? All right. There is a lot more writing on this test than the last test. So questions that you have to write out would be, it says use the words solute, solvent, and solution to explain, and electrolyte to describe a mixture of salt water. So you have to use terms that we've used. Oh, I didn't give this the first hour, but do anyone know what the prefix iso means? It doesn't mean isotope, but what is iso? You learn it in human biology. What? Okay, fine. Iso means same. So an isotope, it's called an isotope because it's still the same element, but we've just changed the number of neutrons. So I use the term isomolar. What does that mean? It says an isomolar solution of, and then it names two things. Okay, it has the same amount of moles of both. You all right with that? Okay. All right, that is all the free response. We got through that a little bit faster. Well, there's more on it, but that's all I'm going to review. The multiple choice, once again, comes from your reading. So I do expect that you've read. All right. I'm just going to read these, and I'm not going to repeat them. But if you want, you can listen to this again over and over and over on the internet when I post it, and go slow-mo, whatever. It says a weak electrolyte exists predominantly as blank in solution. All right. Next, which of the following are weak electrolytes? Next, combining aqueous solutions of barium iodide and sodium sulfate affords a precipitate of BaSO4. Which ions are spectator ions in this reaction? When aqueous solutions of silver nitrate and potassium iodide are mixed, AgI precipitates. Write the net ionic equation, and you just choose A, B, C, D, or E. Of the following elements, blank is the only one that cannot be found in nature in its elemental form. That's a good one. Did I talk about that? Okay, I don't know. Maybe I glanced over it. But that has to do with the activity series. Which compound has the atom with the highest oxidation number? That question takes some serious amount of time because you have to find the oxidation number of all of the things. Number 7, I asked this on a quiz and tons of people got it wrong. Oxidation cannot occur without reduction, right? Don't miss that one. In which species does sulfur have the highest oxidation number? Species just means the things that are there. Which of the following is an oxidation reduction reaction? I gave you some clues there that should be a dead giveaway. What's the number one clue I gave you to know if it's an oxidation reduction reaction? Okay, that's true, but that's not, like you can just look at one and know. There was something that gave it away. I guess I didn't say it enough. I've already said it this hour once. It has to have a lone element. I guess I shouldn't say it has to. But if there is one with a lone element, it will be that one. I'm going too slow. Oxidation is the blank and reduction is the blank. Now it's gain or loss of electrons. Of the species below, only blank is not an electrolyte. Next, which of the following are strong acids? Next, based on the equation below, which metal is the most active? That's definitely the hardest test question on this part. It gives you 3 reactions and asks which one is more active. You can do it, just take some thinking. Which of these metals is the least easily oxidized? Where did the least easily oxidized live on that series? Bottom. Remember, I said you don't have to memorize it, but you need to memorize family 1's at top, and what ones were at the bottom? Your precious metals. That will get you easily onto what you need. Then it says which hydroxides are strong bases. Then it says a neutralization reaction between an acid and a metal hydroxide produces blank. Of the following elements, blank is the most easily oxidized. There's 2 like that. This is math. How many moles of this are present in 0.2 liters of 0.4 molar solution? We did a lot of that in a problem, but we never ask you just straight for it, although I kind of have. And then this one is the same difficulty as one before. Consider the following reactions, and it gives you 3 of them. It says, which is the correct order of increasing activity for these metals? If I remember right, one of those 2 questions is actually incorrect, but you use your data. Like, if you just go straight with the activity series, it doesn't work. But with the data they give you, so anyway. And then the last one is math. There are blank moles of bromide ions in 0.5 liters of 0.3 molar solution. Okay, Monday will be probably another math question and some time to work on it. Anyway, I will see you a week from Monday.